Hi. In every niche you can think about, there are some questions, some debates which can always start an argument. And in the niche of people who are interested in the history of naval warfare over the past century and a half, such a question is whether a particular ship is a battleship or a battle cruiser. And a few weeks ago, I decided that I could surely solve all these debates once and for all, only using a little bit of regex, a little bit of C sharp, and all the arrogance which comes with being a physicist looking at a field they have no training in whatsoever. And the way I'm going to solve this question is by taking a page out of Wikipedia's book. Actually, I'm going to take a lot of pages of Wikipedia's book because I have actually downloaded all the wiki pages for all the battleships and battlecruisers ever built, or at the very least all the battleships and battlecruisers recorded on Wikipedia. And I have used this to extract the power to weight ratio and other stats from all these articles and build, well, a plot like this one you see here, and right now have no clue what means. I will explain in more detail later why I have made a plot like this and what I think we can learn from a plot like this. But first I think it's time for a little history, or at the very least historiography lesson, because I think it's useful to just quickly explain where battleships and battlecruisers come from and what definitions people usually use to tell them apart, and then I will explain why I think the power to weight ratio is a better way of telling them apart, or at the very least why I thought the power to weight ratio might have been a better way of telling them apart before I actually looked at the data. Then I will quickly show you some of my code, the code I used to download these wiki pages and analyze the results, so we can talk about the pitfalls and problems in my code. And finally, we will look at some of the results, like, well, this graph you see here, explain what it means, and try to see if we can draw any conclusions from it whatsoever. Spoiler, we can't, but it's at least fun to try anyway. Maybe there will be some timestamps in the descriptions or whatever. I don't actually know. Right now I haven't made the video yet. Once upon a time, before the age of the missile cruiser, before the age of the aircraft carrier, the main way navies dealt damage to each other was using big guns. Big guns mounted on the principal surface combatant of the navies of the time, the battleship, carrying lots of big guns and lots of armor to protect itself against other navies' big guns on their big battleships. And depending on the time period, a smattering of lighter guns as well. Now, these battleships were intended to fight in a line of battle, with the battleships sailing in a neat line, shooting at the other nation's line of battleships. And the way I like to think about it is that the battleships look like this in a speed, firepower, protection triangle. Essentially, they have lots of firepower and lots of protection to protect themselves against the other nation's firepower. And speed is nice, but speed is secondary to the two other things if you're going to be fighting in a line of battle. At least this is what it would look like for a traditional pure battleship. But there is more to war than just the big decisive battle. There is also logistics and commerce warfare, where one side might send out cruisers, smaller, faster ships with comparatively less firepower and protection, at least compared to full-on battleships, to raid the enemy's merchant convoys. Now, you need some way of countering your enemy doing that, and to do that you need some ship which can easily beat a cruiser. A battleship will certainly do it, but a battleship is never going to catch a cruiser. Instead, you need a ship which is fast enough to catch a cruiser, has enough firepower, preferably firepower comparable to a battleship, and enough protection to survive the attacks from a cruiser. And that is what the basic idea behind the battlecruiser is. They are all firepower, all speed, and not as much protection as battleships. Now, there is this idea floating around that battlecruisers actually are some kind of discount battleship. That is not true. They were designed for a completely different mission profile, at least originally. In practice, battleships and battlecruisers end up looking very much the same. For one thing, they carry the same kind of big guns, and they are about physically the same size. Battlecruisers might even be a little larger to fit the extra machinery spaces required to go so fast. And in practice, battlecruisers would like more protection. I mean, there's a good chance they run into other battlecruisers, so they need to be able to take a hit or two, and who knows, they might even be able to serve as a second line of battle units once they are done hoovering up enemy merchant raiders. And battleships would really like more speed. Speed is always nice, especially when aircraft carriers get invented. Battleships would like to be fast enough to keep up with the aircraft carriers. So in practice, a ship might end up looking something like this. I guess this right here would be a fast battleship, which have traded some protection for some extra speed, but it could also have started out as a battlecruiser design study, which people just kept adding more and more protection onto. And the real problem with this speed, firepower, protection triangle I have been using to explain what battleships and battlecruisers is that it doesn't exist. In real life, we don't have a single speed, firepower, and protection stat we can compare to tell if a ship looks more like a battlecruiser or a battleship. Speed is probably the least complicated. At least you have a max speed, although you both have your max speed and your cruising speed and your max speed at various different kinds of weather, and the fact that navies back then, just as today, are not too keen on actually telling what the stats of their ships are. And the firepower is even more complicated. I mean, how on earth do you tell if one ship or another has more firepower if the one ship has just a single very, very big gun and the other ship has a lot of somewhat smaller guns? That's not really easy to compare, and the most difficult to compare is of course protection, because you have so many stats you can look at. I mean, there is the single thickness of the armor. That's the one you'll often hear quoted as 13 inches of armor, 15 inches of armor, or whatever, but in practice that might just be the belt armor. What about the deck armor, and how much and how modern torpedo defense system does the ship have? And while we are at it, apart from the armor, how many internal subdivisions are there? How many watertight and hopefully blast-proof bulkheads are there, so that the ship can stay afloat even if its armor has been penetrated? And we might even count the damage control equipment aboard the ship and the crew damage control training as part of the protection of the ship. So this speed, firepower, and protection triangle doesn't really exist. It can't hurt us, but it can't help us tell ships apart either. So we need some kind of other definition, some other way of telling battleships apart from battlecruisers. I am not actually going to go through all the different definitions people use for battleships and battlecruisers, all the competing definitions. If you want to hear about them, you could maybe watch Drakenefeld's video on USS Iowa and HMS Hood, and whether or not he considers them to be fast battleships or battlecruisers. He goes through a lot of definitions and why most definitions don't work. Instead, I will focus on the definition I like the best and the one I have based my work here on. And that's the one popularized by a naval historian turned YouTuber, Dr. Alex Clark from the YouTube channel Naval History with Dr. Alex. He argues that battleships and battlecruisers actually exist somewhere on a spectrum which goes from pure all protection, all firepower, dreadnought battleships on one end of the spectrum, and the pure speed and the firepower battle cruisers, dreadnought armored cruisers on the other end of the spectrum. He goes out of his way to argue that there's a difference between battle cruisers, two words which in his opinion are the most pure battle cruisers, the extreme speed and the firepower end of the spectrum, or battle cruisers, one word which have moved slightly closer to battleships in terms of protection. And Dr. Clark argues that it's possible to tell where exactly on the spectrum a ship falls by looking at its internal layout and internal structure. Specifically, if the internals of the ship looks somewhat like a honeycombed structure with lots of subdivisions and watertight bulkheads, it's probably closer to the battleship end of the spectrum. While on the other hand, if the ship has huge cathedral-like engine spaces, it is probably closer to the battle cruiser end of the spectrum. Now, I like this definition. I like the focus not only on the thickness of the armor, but also armor coverage and also internal protections, even apart from armor, like internal subdivisions and watertight bulkheads. But what I don't like is that if I have a ship and I want to find where it lives on the spectrum, I essentially have to travel to the country where the ship was originally built, go into the National Archives and find the technical drawings for the ship. Well, sometimes I can find drawings on the internet, but often I can't. And even if I can find the drawings, like here with the SMS Seydlitz, the battlecruiser of the Battle of Jutland fame, I don't feel like I have the education to tell where this sits on the spectrum. I would really rather like if I had a simpler definition, one where I could use just headline Wikipedia stats instead of looking at the technical drawings. And this is actually where we get to my own definition, however many minutes we are into the video, My idea was that, well, if battleships have all these internal subdivisions and internal protections, surely they are somehow compromising their engine efficiency, at least compared to battle cruisers with their huge machinery spaces. So surely battleships have way lower power to weight ratio, both because of their compromised engine efficiency and also because they're carrying so much extra heavy armor, both internally and externally, compared to battle cruisers. So my idea was actually I want to plot the power to weight ratio of every single battleship and battle cruiser ever built, and hopefully what we will find is that most battleships have low power to weight ratio, fast battleships have medium power to weight ratio, and battle cruisers have very high power to weight ratio. Hopefully with the purest of battle cruisers, the Invincible class, having the very highest power to weight ratio. I even put this idea to Dr. Clark, and he replied that this sounds like a really good idea with no potential pitfalls whatsoever. That is in fact what he said. There's no need for you to read his actual reply on the screen right now. So this is what I want to do, but first I need to decide what on earth I mean by power to weight ratio. By weight I of course mean the displacement of the ships. That is the mass of the water the ships displace. But here I actually run into a slight problem, because Wikipedia doesn't just list the displacement of the ship, because there is no no good agreed upon definition of when you measure the displacement of a ship. I want to go with what is called normal displacement. That is the displacement under normal loading conditions with normal amounts of food, fuel, ammunition, reserve boiler, feed water and crew aboard. Sometimes Wikipedia quotes deep load displacement, which is when the ship has as much as it can absolutely carry, and sometimes, especially in the 1920s and 30s, Wikipedia only quotes standard displacement, which is a compromise category created for the Washington Naval Treaty, which is essentially the same as normal displacement, but for some political reason, reserve boiler feed water for the steam boilers aren't counted. Now, that's a little problem I have to solve, and I think it's easy to explain how I'm going to solve this problem on the whiteboard. So if you could please follow me to the whiteboard. Thank you. So how are we going to get the missing figures? Well, here I have a collection of friendship, a tiny subset of all the data I have collected. As you see here, we have the Bretagne battleship from slightly before World War I, and the Dunkirk and Richelieu battleships from slightly before World War II. And as you can tell, Bretagne is of course missing the standard displacement because she is older than the Washington and London naval treaties, so there is no such thing as standard displacement when she was launched. Dunkirk and Richelieu, on the other hand, are treaty era ships, so they have their standard displacement, but they don't have their normal displacement. They do, however, all have the deep load displacement, and immediately it's tempting to say, okay, well, we have the ratio betwixt this thing and this thing. Surely the ratio between this thing and this thing is the same as the ratio between this thing we don't know and this thing. And yeah, that's exactly what I've done. Of course, with a bit more work. I have calculated the average ratio between normal and standard displacement, normal and deep load displacement, and even standard and deep load displacement for all ships of every single nation on a nation by nation basis. And I've also calculated the standard deviation just to see if something crazy is going on with the data. And essentially my idea with doing that was that, well, France is facing roughly the same strategic situation in 1913 as she was back in 1935. Oh, well, that was the other way around. 1913 is slightly before 1935, the more you know. Well, she has the same empire, roughly. She has the same potential enemies, that being Germany and Italy. So I imagined that the ratio between normal displacement and deep load displacement she was going to use when she built the Bretagne was the same as when she built the Dunkirk and the Richelieu. And that's why I think it's somewhat justifiable to calculate this average ratio for France and then just use this average ratio to get from here to here. Now, I've done this, as I said, for every single nation, or everything Wikipedia labels a nation. That is, Wikipedia, for example, labels Nazi Germany as a different nation from the German Empire, but I do actually think that's very justifiable. They have completely different naval situations. For one thing, the German Empire had, well, an empire. Nazi Germany did not have a global empire they needed to protect. So in that way, I actually think that's justifiable. And I was lucky that there were enough ships in this list I downloaded, enough ships which just so randomly happen to have both standard and normal displacement and both normal and deep load displacement, that I was able to get this ratio for every single nation. So therefore I was able to calculate the normal displacement for every single ship I downloaded, even when that data was missing from Wikipedia. Of course, the other side of the equation I also need to get is the power. And in my case, I decided I wanted to use the shaft horsepower, that is the number of horsepowers going into the shaft and the screws of the ship. And, well, sometimes Wikipedia just includes that in the article. Other times Wikipedia includes the power of the engines, that is the number of horsepowers produced by the engine. In that case, I simply assumed a 95% engine efficiency, so multiplied the number of horsepowers coming out of the engine with 0.95 to get what I expect is the number of horsepowers going into the screws. So that way I was able to get the normal displacement and the shaft horsepower of every single battleship and every single battlecruiser ever built. But I think I'm getting a little ahead of myself. I think I forgot to mention how exactly I downloaded this incomplete data of Wikipedia in the first place. So let's look at that now. So, welcome to Wikipedia. This is the starting point of this article here is the starting point of this project. This is the list of battleships. A list of links to articles for every single battleship ever built, every single dreadnought and pre-dreadnought type battleship ever built from 1890 to sometimes in the middle 1940s. If we click on any of those links, we get to the Wikipedia article for each and every single one of these battleships, and here we can simply read off the displacement. This would be the normal displacement, and the power IHP. I assume that means indicated horsepower. Please correct me in the description if I'm wrong about that. Anyway, there are a lot of ships here, and originally my idea was that I would manually read off all the articles for all the ships. Alas, that do seem to be a lot of ships, as in really a lot of ships, as in those ships just keep coming and they don't stop coming. Yeah, that's a lot of ships, like really a lot of ships. Yeah, manually reading off all this data was simply not a feasible thing to do. Instead, I have created a little C# script to do that. Let's take a look at my code. Battleship scraper. Now, there is a lot of code here. You can look at it. The GitHub page is linked in the description below, I hope, if I remember it. If I didn't remember it, then the GitHub page is not linked in the description below. Now, I'm not going to go through all my code. The important part of my code is this thing here, where I have an URL for some sort of Wikipedia page. Wikipedia.org/something something API, and the title's equal to in case you don't know, this is basic C#. It just means I insert one variable into this longer string here, and that variable is this word, list of battleships. So this whole query here, which I here do some pretty basic C# to get an HTTP request from this page and get the content as a JSON file. This Wikipedia page is the same as this page here. This is what it actually looks like, what we actually get when we make this HTTP request. This is ugly, but this is machine readable. It's just a JSON object, and if we quickly switch over to a more human readable format, we see that there are a bunch of JSON elements, and the only important element here is under the element query. There is an element pages. There is a single page here. This page has a single revision 0, and the revision 0 contains an element star, which includes all of this text here. And if you have any experience editing Wikipedia, this should look familiar, because this is Wikitext. In fact, this is the same text you see if you go to this article here and click at the very top, edit. this is the same ship, just without all the line breaks, or rather the line breaks are explicitly written as \n in this text here. So making an HTTP GET request on this URL here essentially gives us something which contains the wiki text, and in case you know C#, you can tell that I'm just extracting the wiki text here. If you don't know C#, don't worry about it. The main point is that here I have extracted the Wikipedia text, and now we need to do two things. First thing first, we need to loop over every single ship in this table. So every single row in this table we want to loop over, and then we want to find this link here to the Wikipedia article, go to that link and do something more to read off the displacement and the horsepower of the ships. And if we go back to the wiki text, we see that the list starts here. There's a bit of a header, and then every single entry, every single row starts with a vertical line, a dash, and a new line. And we can use that to find every single entry. Because what I do once I have this wiki text is I run a regular expression, a regex here, on this wiki text. Regex is essentially, if you don't know, an advanced search and replace programming language, so to speak. Now, I'm not going to pretend this is a simple regex. This is in fact an ugly regex, like every single regex is an ugly regex. But what this here long and confusing statement does is, first thing first, it looks for something which comes after this. Something which comes after this, and this is / vertical line dash \n. \n just means new line character, and / vertical line just means vertical line. So it looks for something which comes after a vertical line and a dash and a new line. And well, that's the case for every single one of these rows here. So this regex looks for every single row, and inside every single row we note that we have a Wikipedia style link here and here and here, and well, at the start of every line we have a Wikipedia style link to the Wikipedia article for the ship. And we actually search for that here. Now this is a little confusing to read, but the $? Just means anything or nothing. There could be any number of characters between the start of the line and this parentheses here. This parentheses here is a capture group in regex. That means that we save whatever is inside of this parentheses and do stuff with it later. And then we have double brackets start and double brackets end, and another anything capture character which literally captures anything. In this case, this captures anything between a double bracket start and a double brackets end, and that would simply be this link here or this link here. Now this is a Wikipedia style link. A little more work is required to turn this into a URL we can get the article from, but not a lot. In some cases these links start with SMS or HMS or USS or whatever prefix the Navy uses. In that case it's immediately followed by the name of the ship, and maybe not some kind of a disembarkation, which is essentially some number, some identifier which can tell ships apart from other ships which have the same name. There were, for instance, some I think third-rate ship of the lines named HMS Africa. And in the case of Africa, the URL to the article for Africa It's open here. That's just HMS underscore Africa underscore and then the disembarkation, in this case 1905. The disembarkation could be literally anything. It could be the hull number, it could be the pendant number, it could just be a plain number, it could be the year the ship was launched, it could really be anything. I don't actually know what this 2 here means. I don't use that to create the link. Now, some ships don't have a prefix. Some ships will be written as ship, Japanese battleship, Arky. In this case, no disembarkation, because Japan only built one battleship named Arky. In that case, the link is Japanese underscore battleship underscore the name of the ship, possibly underscore the disembarkation, but there is no disembarkation in this case. So if we click this, we see that this is the URL. So it's a fairly trivial matter to take this first capture group, which I take right here. After we right here loop over every single thing which matches this regex, which essentially means looping over every single row in this table here. It's a fairly simple matter to take this Wikipedia style link from the first capture group and turn it into a URL we can get. We can use an HTTP GET request from and get the full article. Now, once we have gotten the full article, there is a bit more work. There's a bit more work. We need to get the displacement, and we need to get the installed power, and we need to deduce what sort of unit this is in. Okay, that's a little confusing. This ship doesn't explicitly write if it's deep load displacement or normal displacement or standard displacement. In that case, I just assume it is normal displacement. But how are we going to find this? Well, if we click edit again, so we see what the computer sees when it downloads this wiki text, we see that let's see, install displacement is here. Displacement is always, or it's always supposed to be inside a Wikipedia convert statement. A Wikipedia convert statement is some sort of template statement which converts a number, in this case in long tons to normal tons, but could also convert short tons to metric tons or metric tons to something else. It is essentially the thing which generates this piece of text you see here. And since convert statements are fairly standard, it's again possible for me to search for convert statements which convert tons to something or something to tons using another regex. I've done this in this other class, the ship class, which stores all the data. And let's see. This is what this regex look like. Now, I'm not going to pretend this is a simple or easy to read regex. In fact, it's the ugliest regex I ever created. Yeah, it just keeps going. Yeah. It's an ugly regex because there are many different valid ways of writing a convert statement in Wikipedia, and my regex also needs to capture whether or not this is normal displacement or standard displacement or deep displacement, with all different ways people might write that. But I have a regex I can use. I can use, and when I use this regex, I can get, in this case, I always go with the lowest number just for consistency if there are multiple numbers. In other cases, there is just one number, like here. So I can get this displacement, and using a slightly simpler regex, I can get the number of shaft horsepowers. of the ship. Some conversion is needed. I need to convert between kilowatts or horsepower, or convert from convert to metric tons from long tons or short tons, but that's a fairly easy thing to do. After all, the convert statement conveniently tells me what sort of unit the data in the convert statement is written in. So I haven't gone through in detail how my code works because it is rather lengthy, but these are the broad points of my code. I'm able to download this data I'm interested in from Wikipedia. Of course, apart from that, there is a lot more work. For instance, I make multiple attempts at getting the URL. I have a primary link I try to go to, and if that doesn't work, I randomly try without the disambiguation. I may try with the slightly different formatting because sometimes I just fail to get the correct link because my original regex I showed you is not perfect. And I also allow manual overrides. I have actually made a table. I have manually created this table called Battleship Corrections.comma separated values, which are 40 ships where I know my program fails to get the correct displacement or the correct horsepower for one reason or another, often to do with the formatting errors on Wikipedia itself. I mean, if Wikipedia is ill formatted, then my regex, which assumes it's correctly formatted, doesn't work. There are 40 odd ships where I had to do that, but that's so in that case I manually went into Wikipedia and read off the data, but that's still way better than doing it for all 316 ships. And well, armed with these corrections and the things it can download off Wikipedia, my program has produced, let's see, battleships normal power the CSV, this comma separated values file, which contain all 316 battleships on the Wikipedia list, and label their shaft horsepower, their normal displacement, even their speed. I decided to get that as well, the year they were launched, and their power to weight ratio. This is everything I wanted, and armed with this I can simply go plot the data, and I think that's what we should take a look at now. This is our data. I don't really think I need any more explanation. I mean, the plot really speaks for itself. Okay, I will explain what on earth you're looking at, because you have no idea what you're looking at here. This is the power to weight ratio of every single battleship and battlecruiser. By the way, I got all the data for the battlecruisers manually. There weren't a lot of them, there were only around 20 or so. And the Wikipedia list had a slightly different format, so it was faster and easier for me to just get the data manually. The power to weight ratio is plotted on the y-axis, and I decided to plot the displacement on the x-axis. I thought that was useful because it splits up the data points, so all the data points aren't on top of each other, and we will also get to see how displacement overall increases over time. At the same time, as you can see, there are a lot of lines in different colors. The different colors, as you can tell, represent different nations. Points which are stars are battlecruisers, and points which are solid O's are battleships. And in general, the lines just means when the ship was built. The lines go from the older ship to the next newer ship, and so on. Now, it's probably still a little confusing what you're looking at, so I think we will simplify this by going back to the very start to 1890, the arguable start of the pre-Dreadnought battleship era. There isn't a lot to see here. There are just a few ships built by a few powers: the Russians, the Germans, the French, and the British. All ships are pretty much the same displacement and pretty much the same power to weight ratio, at least compared to ships we'll get to see shortly. As time marches on, people build more ships, and here you can really see that lines being connected, showing how do I put it, is which ships are built when. Not a lot is going on. No ships are really standing out in terms of design. Let's just move on. Yeah, some of the text are slightly on top of each other. I made this plot in Python, and I'm not particularly good at Python. Well, people keep building battleships, and now more people enter the race. The Americans are already here with a few ships, and the USS Iowa, not the one which is currently a museum ship, an older version. The Italians have entered the race. We're also going to see the Austro-Hungarians and the Japanese shortly. I completely missed them. They bought a few British pre-Dreadnoughts, and now they are going to start building their own pre-Dreadnought battleships. The names are really on top of each other. Sorry, it's not my fault that everyone keep building ships at roughly the same displacement and roughly the same power to weight ratio. Now, supposedly we are in a naval arms race between Germany and Britain, though you really can't tell from looking at this plot, because the British are winning this so decisively. They have a huge infrastructure advantage compared to the Germans. Here we have the Austro-Hungarians. Still, there isn't a lot to say here. I'll just move ahead until we get to 1906. Okay, a lot of ships are being built, but we are about to get to 1906, and a revolutionary ship is about to enter the water. A ship which is going to look completely out of place compared to all these other ships in this plot, and that is, of course, HMS Invincible, the first battlecruiser. And Dreadnought, the first battleship, the first Dreadnought-type battleships. Both these types of ships are powered by the revolutionary new steam turbine, which offers drastically improved power-to-weight ratio for machinery compared to older triple expansion steam engines. Now, in the case of Dreadnought, all this more efficient machinery has been used to is carry way more guns and way more armor. But in the case of Invincible, the designers looked at this power-to-weight ratio and asked, okay, how fast can we go? And the answer is very fast. And this ship has very, very high power-to-weight ratio compared to anything ever built before. Well, okay, with the exception of a few lighter ships like destroyers and cruisers, also powered by steam turbines. As I said, as I already talked about, these ships are designed to chase down and destroy commerce raiders in cruisers. And now Dreadnought has completely revolutionized the battleship building game. Everything built before Dreadnought is arguably obsolete now, so other people are going to start to build their own Dreadnought battleships. And here they come. Unfortunately, displacement have gone up after Dreadnought, but displacement have gone up pretty uniformly, and power to weight ratio is still around 1, so all the names are on top of each other. Sorry about that. Again, it's not my fault. Other nations are starting to build Dreadnoughts. We have the Nassau and Posen here, German Dreadnoughts, and we have the South Carolina, arguably an American Dreadnought, though that one is debatable. Some consider it the very last and most capable pre-Dreadnought. Oh, and the Germans got into the battlecruiser building game as well. Now, I said my hypothesis was that the high power-to-weight ratio indicates that you are on the battlecruiser end of the spectrum. The German battlecruiser here, von der Tann, doesn't look to have to have the same power to weight ratio as the British battlecruisers. If my hypothesis is correct, this probably means it's more towards the middle of the spectrum, but still clearly on the battlecruiser side of the spectrum. So far my hypothesis is looking fairly good, but we're going to get some ships which are going to completely break this. Let's start with the Gangut class Russian battleships. They have very high power to weight ratio. Like, by this logic, if my hypothesis was correct, they would be considered battlecruisers, yet I have not heard anybody seriously argue that they are battlecruisers. I honestly hoped this was an error on my part or an error on Wikipedia, but as far as I can tell, they really do have this monstrously high power to weight ratio. Oh, in the meantime, everyone keeps building dreadnoughts and everyone keeps building battle cruisers. The Argentinians are buying some British battleships. Yeah, we're about to get into World War One, and a lot of ships are going to be built, as in really a lot of ships. And now the British have also introduced the Queen Elizabeth class battleships, not the aircraft carrier, but the battleships. We have Queen Elizabeth and Warspite being launched here. They're also building some more traditional ships, but these are the first arguable super dreadnoughts, arguably another huge jump in capability. Oh, the Japanese have also bought their Congo class battlecruisers of the British. Yeah, again, sorry, the names are all on top of each other. And right now we have another problem. Zetlitz has very high power to weight ratio. I am not sure, this might be an error. I don't know for certain. But well, people are building more battlecruisers and more battleship. Now World War One is in full swing. The British are churning out Queen Elizabeth as if they are some sort of Queen Elizabeth factory. And right now we have the Ismail or Borodino, a Russian class of battlecruisers which apparently have lower power to weight ratio than the Queen Elizabeth class battleships, and this really kills my hypothesis. My hypothesis that you could use the power to weight ratio alone to tell battlecruisers apart from battleships, because either you're going to say that Borodino are actually battleships, or you're going to say that the Queen Elizabeth are actually battlecruisers, or you're just going to admit that maybe power to weight ratio is not as good a way of telling these types of ship apart as I originally hoped. Well, be that as it may, people are going to continue building ships. They really can't stop, and right now the British really seem to be pushing power to weight ratio. At least I am not 100% certain there haven't been a mistake here. I think this data for HMS Claudius and Courageous and later Furious are from their battlecruiser form. I don't think it's from their later carrier conversion. But well, apparently Repulse and Renown, the battlecruisers of which are mostly famous from World War II, have rather high power to weight ratio. Again, sort of invalidating my hypothesis, because they are certainly not more towards the battlecruiser end of the spectrum compared to the original HMS Invincible. They are certainly battlecruisers, but they are not more battle cruiser with emphasis on cruiser than Invincible. The Germans are building a few more ships. We are getting a few American and Japanese ships, and now World War One is about to be over. Now construction is going to slow down. Yeah, we just got Furious out, armed with 18-inch guns. She is going to be sensibly converted to an aircraft carrier soon enough. Yeah, you can't see the name Fuso here. It's outside the screen because I'm apparently not that good at Python. I don't think there is much to say. Let's just move on. Oh, now we finally got Hood, one of the most aesthetically pleasing ships ever put to sea, and the T3 design study, which I think is even more aesthetically pleasing, but it was never turned into a functioning battlecruiser. Some people argue that the T3s are actually full-on fast battleships. Is there anything else to say? Not really. We are getting some standard class US battleships which are mostly famous for being destroyed at Pearl Harbor through no fault of their own, of course. Hood is also a controversial ship. Some people argue that Hood is actually the first true fast battleship in the world. Well, she's certainly fast, and she carried the same kind of guns as the Queen Elizabeth class battleships, the exact same kind and the exact same number, and she arguably has the same armor thickness depending on how you count the inclination of the armor, but she doesn't quite have the same armor coverage as far as I know. So I am decidedly undecided as to what Hood actually is. Moving on, we got the Japanese Amagi that was actually converted to an aircraft carrier and then destroyed in an earthquake before it was launched, but it would have been here very close to Hood if it was completed as a battlecruiser. Oh, and now we're going to get the USS Lexington as a battlecruiser. She would of course also be converted to aircraft carriers. A common fate for battlecruisers indeed. Oh, and now we got the Nelson and Rodney. I know I've said aesthetically pleasing a lot, but these are probably, in my opinion, the most aesthetically pleasing battleships. And now we are into the Washington Naval Treaty. There is going to be a 10-year battleship building holiday where nobody are building anything. So we're going to skip ahead 10 years. Now we are suddenly not that far before World War II, and the French just launched their Dunkirk class fast battleships. Again, this is a controversial ship. It has only 13-inch guns. Some people argue that makes it a battlecruiser. Some also argue it's a battlecruiser because it's mainly designed to fight the German very heavy cruisers, the Deutschland class heavy cruisers, which some people label pocket battleships, but they are clearly cruisers. They are not battleships, so they aren't even on this list. We also have the Strasbourg, a sort of half sister to Dunkirk, built later, aimed more at countering the German fast battleships Scharnhorst and Gneisenau. Something else has happened. The Japanese took the Congo-class battlecruisers in for a major refit, replaced the machinery and added some more armor and slapped the name fast battleship on them. That's again controversial. Historians disagree on whether you can change the class of a ship by just refitting it slightly, and even if you can, whether it's right to call the Congos fast battleships after this. Again, I'm decidedly undecided. The Italians have also gone into the fast battleship building game with their Littorio and Vittorio Veneto battleships. They also have higher power to weight ratio than some battlecruisers, which really breaks with my idea that you could use power to weight ratio to tell battleships apart from battlecruisers, because this has higher power to a weight ratio than HMS Invincible, and it may be a fast battleship, yes, but it's not further towards the battlecruiser end of the spectrum than HMS Invincible, because nothing is. We also have these German ships, Scharnhorst and Gneisenau. They are also controversial. They are only armed with tiny, relatively speaking, 11-inch guns. Some people argue that makes them battlecruisers because they would lose a fight with any other battleship. I don't think having low firepower makes you a battlecruiser, and they didn't exactly sacrifice firepower for the sake of gaining more speed. They sacrificed firepower because that was all German infrastructure could produce, given that they had been utterly savaged by the Treaty of Versailles. And the Stjernhorst and Eisenhower were really design studies for the later Bismarck, which is going to come along here as we are moving into World War II. We have Bismarck and Tirpitz. They also have higher power to weight ratio than several battle cruisers, really putting yet another nail in the coffin of my original hypothesis. Getting some more French fast battleships, and the the British, that's the red color, are getting into the fast battleship building game with their King George V class. Actually, they're going to continue turning out King George V as if they're some sort of King George V factory now. Oh, and the Americans just got into the fast battleship building game with the North Carolina. Fitting indeed that North Carolina marks their entry into the fast battleship game, while South Carolina arguably marked their entry into the Dreadnought battleship building game. Oh, and the Japanese completely broke this figure by introducing Musashi and Yamato, which are completely off the scales in terms of displacement. We're getting some battlecruiser design studies by the Dutch, by the Germans, by the Soviets, but none of them ever came to fruition. And now battleship building is going to come to a stop. We are going to see the final there we go. We are going to see a final line of fast battleships, the Iowa class battles. Oh, did I double skip? Apparently the name Iowa is missing, but these are the Iowa class fast battleships of the American Navy. Oh, and we're also going to see some Alaska class. Wikipedia labels them battlecruisers, that's why they appear here. I am unsure what exactly they are. If anything, they look like Dreadnought armored cruisers to me with their 12-inch guns. Nobody really agrees if they count as battle cruisers or if they just count as very heavy cruisers. But right now we are in the age of the aircraft carrier. Battleship construction is going to stop. We are going to see some abortive design studies by the Soviets, but that didn't ever come to fruition. I don't consider the Russian Kirov class to be the same as battle cruisers, even though it is officially labeled a battle cruiser. So this is the end of this data set, and this is the end of this figure. Now we are finally back at the figure you saw at the beginning. And have we learned anything?
Well, no. I don't think we have a good way of telling battleships apart from battle cruisers. What I was hoping was that my head is clipping out of the frame. I'm trying to stay here like this. I was hoping we'd get a simple plot with all battleships here at the bottom, fast battleships in the middle, and the battle cruisers on top with the power to weight ratio on the y-axis. Instead we got something which looks like this. We have our pre-dreadnought battleships here at low displacement and low power to weight ratio of around 1. Then we have our dreadnought type battleships roughly here with the power to weight ratio of around 1 and somewhat higher displacement. And then we have our battle cruisers up here. That was very good. I liked seeing that our original battle cruisers have way higher power to weight ratio than our original battleships. But then generally over here on the plot we have our fast battleships which have exactly the same power to weight ratio as our battle cruisers, and this includes not only controversial ships which somebody argue are actually battle cruisers disguised or reclassified as fast battleships. It includes stuff like the Bismarck, which nobody in their right mind arguing are actually battle cruisers. So what can we conclude from this instead? Well, I guess Dr. Clark was right in his actual reply to me where he said that a problem is that machinery gets more efficient over time, and with some of these more modern ships, machinery has maybe gotten so efficient that you can carry battlecruiser-like power-to-weight ratio with battleship-like protection and internal subdivisions. And that's probably what we are seeing here. Now, I do imagine if people had continued building battlecruisers at the same time as they were building World War II era fast battleships, maybe those battlecruisers would have had power-to-weight ratio way up here and be traveling at 40 odd knots. But there was just no need to build such ships. If technology has evolved to a point where you can build an all-speed, all-firepower and all-protection fast battleship, why would you want something that ridiculously fast? Is there any other conclusions we can draw? Oh yeah, one thing I felt was a little weird was that Yamato and Musashi are way down here on the graph. They have somewhat low power-to-weight ratio, even though they are also officially labeled fast battleships. But honestly, I am not sure I agree calling them fast battleships. They are really a category of their own, and they aren't that fast. I consider them more semi-fast battleships. So I don't think there is any nice conclusion I can draw. I am certainly not in a position to say that a controversial ship like Hood is definitely a fast battleship or definitely a battlecruiser. Same goes with other controversial ships here. I guess I haven't added anything to the debate other than I got a nice graph and I did download a lot of data from Wikipedia, and at least we got to go through the history of ships in the late 19th and mid 20th century. At least that was something. So I guess maybe the title of the video was clickbait, and I guess the video is over now. You can go now, and while you go, feel free to click any of those random buttons down there. I don't think they do anything, but feel free to click them if you want to. But please don't click the subscribe button. I do plan on uploading more videos, but they are going to be nothing related to naval history, so if that's why you watched this video, just don't click the subscribe button. Thanks. You can go now.